Section 2.1 is about functions. I would pause the video and write down these notes. A function is a relationship that assigns every x value to a single y value. So for example, over here, this is not a function because x equals 2 goes to y equals 3 and x equals 2 goes to y equals 4. The way that we write function notation is with this f of x. It's not f times x, it's f of x. And then the independent variable or the argument are all the x values or the domain. One tool that we have to test if something is a function is by the vertical line test if we have the graph. And that means if you draw a vertical line anywhere on the graph, it only hits the graph at one point. So for example, on this first one, this is a function because no matter where you draw the vertical line, it will only cross the graph once. This one is not a function because you draw a vertical line and there's one x coordinate with two different y coordinates. So it's not a function, it fails the vertical line test. So evaluating a function, whenever you have a function like this one, f of x equals 2x squared minus 3x, whenever you see that like this f of negative 3, that means take every x in the function and replace it with a negative 3 and evaluate. So go ahead and pause the video and try that. So if I replaced every x with a negative 3, so 2 times negative 3 quantity squared minus 3 times negative 3, and then used order of operations to evaluate this, what this means is that if you have an x coordinate of negative 3, its y coordinate is 27. You can also have things outside of the function notation. This means you multiply the entire function by that. So go ahead and pause the video and try negative f of x. Simplify that. So if you have something on the outside, that means it goes to everything. So you have negative, well, f of x is 2x squared minus 3x. And then I distributed that negative sign, so the opposite of f of x is negative 2x squared plus 3x. So you can do more than that. Here we have an x plus 3 inside the parentheses. We want f of x plus 3. Whenever you see something inside a parentheses, you replace all the x coordinates with that, or all the x's in the original function with that. Here you have f of x minus f of 3, so kind of a combination of these two. So go ahead and pause the video and try to simplify the bottom two. So on this first one, you have f of x, so f of x was just 2x squared minus 3x, and we want to subtract f of 3. So every time I see an x, I'm going to replace it with a 3. So you end up with 2x squared minus 3x, and then this simplifies down to a minus 9. Over here, every time you see an x in the original function, you're going to replace it with an x plus 3. So you have 2 times x plus 3 quantity squared minus 3 times x plus 3, and then simplify everything out, FOIL everything out, you end up with 2x squared plus 9x plus 9. So we have the same function again, so go ahead and pause the video and try f of negative x. So replace every x with an opposite of x. You get 2 times the opposite of x quantity squared minus 3 times the opposite of x. Negative x quantity squared is just x squared, so you end up with 2x squared plus 3x. So this thing down here, f of x plus h minus f of x over h, is what's called the difference quotient. You need to know how to do this. You will see it throughout the entire school year. It is a fundamental part of calculus, but it's just using these function skills that we've been talking about. So this first one says f of x plus h. Anytime you see something inside function notation, that means you replace every x with that, and then you're going to just subtract f of x from it. So every time I saw an x in the original function, I replaced it with an x plus h, so 2 times x plus h quantity squared minus 3 times x plus h, so that's just the f of x plus h part. Then I'm going to subtract the original function back off. Make sure you put parentheses around it so it's going to both parts and not just the 2x squared. So you have minus the quantity 2x squared minus 3x all over h. So all I did was transfer this notation and just filled it into the actual given function. So now go ahead and pause the video and just FOIL everything out as far as you can. So if you FOIL everything out, you end up with 2x squared plus 4xh plus 2h squared. So that's just from the 2x plus h quantity squared part. And then from this part, you get minus 3x minus 3h. Make sure you distribute that negative with it. And then the last part, make sure you distribute the negative. You end up with negative 2x squared plus 3x. So now at this point, you'll see some things will start to cancel. The rule of thumb is everything without an h must cancel. If it's not canceling, if something without an h isn't canceling, you did something wrong. Every single one of these problems, everything without an h has to cancel. So if we look at this here, we have a plus 2x squared and a minus 2x squared. We have a minus 3x and a plus 3x. Everything else has an h in it. So again, everything without an h has to cancel. The reason for that is now we're going to factor out that h. You have an h in your 4x h here. So I'm going to factor out that h. You're left with 4x. You have an h in 2x squared, so 2h squared. So I'm going to factor out that h, and you're left with a 2h. And you have an h in this negative 3h. So I'm going to factor out an h. You're left with just negative 3. And all of this is still divided by h. The reason that everything without an h must cancel is because you have to be able to cancel off these h's. You have an h in the numerator and you have an h in the denominator. That gets back to the reasons for it in calculus, but for here, everything without an h must cancel so that you can then factor out and cancel off that h. So your final answer is 4x plus 2h minus 3. You will see this on probably every single test from here on out until the end of the school year. So this should be an easy 10 points. Make sure you know how to do this. The domain of a function are all the values that can be taken by the independent, usually x, variable in a function. These can be affected by a real-world situation. So if there's a real-world situation, it trumps just a regular functions domain. But these are if you just have a regular function without any kind of real-world situation. So I would go ahead and pause the video and write down these domains. Polynomials, there's no issues. You can plug anything into a polynomial, so their domain is all real numbers. Rationals, which are the same thing as fractions. Remember, you cannot divide by 0, so whatever's in the denominator cannot be equal to 0. And then square roots, remember, we can't take square roots of negative numbers, so whatever's inside the square root must be 0 or positive. So using those notes from the previous slide, here we have 4 functions. Go ahead and pause the video and find the domains of each of these functions. So this first one here is a quadratic or a polynomial. Since there's no context to it, just like we talked about on the previous slide, our domain is all real numbers. This notation here means x is included in, this little e symbol means included in, the set of all real numbers. If you haven't go ahead and moved on to the next ones, go ahead and pause the video and find the other 3 domains. So for this next one here, we have a square root. We said that whatever's under the square root must be greater than or equal to 0 or can't be negative. So I took what's under the square root and I set it greater than or equal to 0. So you have the absolute value of 4 minus 3t is greater than or equal to 0. Because this is an absolute value is always greater than or equal to 0. So in this case, t again is all real numbers. That's strictly because of these absolute value symbols already restricting it to positive or 0 numbers. For the next one here, g of x, we have a rational function. We said we cannot divide by 0. You cannot have a 0 in the denominator. So I set whatever was in the denominator not equal to 0. So x squared minus 4 does not equal 0, which means x squared cannot equal 4. So x cannot equal either positive or negative 2, because 2 squared is 4, negative 2 quantity squared is also 4. This last one, we have a little combination here. We have a rational, so I set that up over here. I said the square root of x plus 5 cannot equal 0. So I solved that for x, and I got that x cannot equal a negative 5. And then I also have a square root, so I set that one up. X plus 5 must be greater than or equal to 0. So x must be greater than or equal to negative 5. So I combined these two together, and I said that x must be strictly greater than negative 5. And that's because of the combination of the square root and the rational. So sometimes you're just going to have a basic one. Other times you might have a combination, in which case you have to take everything that you know into account. Operations on functions. If you have 2 functions, f and g, then you can add them. You just add the 2 functions, combine like terms. You can subtract them, combine like terms. Make sure you distribute that negative all the way through the second one. You can multiply them. A lot of times you might need FOIL, some kind of distribution method. Or you can divide them as long as wherever g of x is not equal to 0. If Here we are given two functions, f of x equals x squared plus 9 and g of x equals 3x plus 5, and we want to find f minus g of x and f divided by g of x. So go ahead and pause the video and do f minus g of x and then find the domain of that function. So to do f minus g of x, we do f of x minus g of x. So I have x squared plus 9 minus the quantity 3x plus 5. Make sure you distribute that negative all the way through. So you get x squared plus 9 minus 3x minus 5, and then combine like terms, and we usually also write it in power order, so x squared minus 3x plus 4. This is just a polynomial, so its domain is all real numbers. So go ahead and pause the video and try f divided by g of x. So on this one, f divided by g of x is the same thing as f of x divided by g of x. So I have x squared plus 9 over 3x plus 5. There's nothing you can simplify, so that's just your answer there. And then the domain, this is a rational function, so the denominator cannot equal 0. So I set the denominator not equal to 0 and solve for x, and got that x cannot equal negative 5 over 3. So this section has been a review of functions.